Good morning. Today we learn class 12th physics lesson first. The name of the lesson is electric charges and field. Our today's topic is dipole moment in external electric field, or how much torque will be acting when the dipole kept on external electric field. So we start. Electric dipole kept in external uniform electric field. If the dipole kept in external in an electric field, what happens? Let us consider. Consider an electric dipole if it is a dipole, then it has two charges, positive and negative charges. Okay, consisting of charges charge positive Q and negative Q. And of length we know that the length of the dipole is 2L. Placed in a uniform electric field uniform electric field should be represented by E vector, making an angle that angle should be theta, the angle between electric field and dipole. With it, it has a dipole moment we know that the magnitude of the dipole moment is P vector equals to 2QL, or you can write Q into 2L. Both are same. It depends on you whether you wanted to write this one or that one. Okay, let us make the diagram. of the dipole with the electric field. Suppose it is a uniform electric field. A dipole of length 2L. Suppose this is negative charge and this one will be positive charge. And the distance between these two will be 2L. We know that the force acting on the dipole, suppose this is force 2, F2, and this one will be F1. So here force equalized to QE. Here again QE. How it will be happens? You know the formula. Electric field equalized to force upon charge. So F equalized to QE. Okay. And the angle between the electric field and the dipole is theta. This angle. Suppose this is a point A. This point is B, and this point will be C. This distance BC equals to 2L sine theta. How it will be happens? Sine theta equals to perpendicular upon hypotenuse. Okay. Perpendicular is equals to BC upon hypo equals to BA or AB. So BC equals to AB sine theta, or BC equals to the distance between AB will be 2L sine theta. Okay. So here BC equals to 2L sine theta. We got it. So from above diagram, the force exerted by positive charge on charge positive Q by the electric field E vector is equalized to F1 equals to QE. Which direction? Along electric field. Then force on charge negative Q by electric field it is in opposite direction. F2 equals to negative of QE, opposite to electric field. So total force will be equalized to F1 plus F2. So net force on dipole F equals to F1 plus F2. Okay, these two equations. This is the first equation, or this one will be the second equation. Here we got it. So total force equals to F equals to QE plus minus QE. So F total will become, or F net equals to 0. From here we can say that there is no translating force acting on the dipole, or net translating force equals to 0. But there is two equal and opposite forces acting on the dipole. These equal and opposite forces or couple of forces make torque. Okay, so here we can write the net force on an electric dipole in a uniform electric field is 0. Okay, do not have any linear momentum. If it is not have any linear momentum or translating movement rotation, in that case we can write hence the net translating force on a dipole in uniform electric field is 0, but the two equal and opposite forces acts as it at distant point. That distant point will be A and B, okay, of the dipole. They form a couple which exert a torque. Here the new word come into existence. That word will be torque. A torque equals to, you know, equals to either force multiplied by perpendicular distance between two forces, okay. When we see the diagram is look like this. The two charges, negative charge and positive charge, like this, okay. This point A, this B, and this is C. F2 equals to negative QE, F1 equals to QE. This is the theta angle. So tau equals to, torque is represented by tau. Tau equals to either force. That force should be QE. So QE multiplied by perpendicular distance, this distance BC, or torque equals to QE. That distance should be equals to 2L sin theta. Oh, sorry, sin theta. We already find out that. So torque equals to 2 Q and L. So we take 2 Q L E sin theta. 2 QA, this 2 QL equals to P. the dipole moment. Okay, you already know about that. So torque equals to P E sin theta. As the direction moves upward, the torque tau is perpendicular to the dipole moment. Or so we can write the vector form. In the vector form, tau equals to P E. This is the vector form of the torque. Suppose the question arrives on our mind, on which condition the torque is maximum. Torque is maximum when theta equals to 90 degree. Okay, or the dipole is perpendicular. So here you can write the torque on the dipole will be maximum when the dipole is perpendicular to electric field. Okay, so you can write tau max equals to tau maximum equals to PE sin 90 degree. Sin 90 equals to 1. So here you can write P into E. So here you can find out the maximum dipole moment or maximum torque on the dipole. Okay. If you like this video, like it, subscribe it and share it. Thank you.